Hello friends, let's see our second problem, which is the soft bubble problem. In soft bubble, you can see here is two surface, the inner surface and the outer surface. The inner surface is also is contact with air, and the outer surface is also contact with air. So when the pressure P, the excess pressure P is increases to P plus dP, what happen? The inner surface is expand as well as the outer surface is expand. But in case of soft bubble, you can see this is a very thin film. So what we can do, we can consider that the inner surface and the outer surface area is same. So increment in surface area is equal to twice of the surface area, increment of surface area for a single surface. This is actually a mistake. It is 8 pi r dr, like what we have derived before. You can see here 8 pi r dr increment in the surface area for the liquid drop. So here actually two surface is present, inner and outer, and the inner and outer surface is equal, very nearly equal. So we can just multiply 2 into 8 pi r dr. So since the area is increased, the increment in potential energy is equal to twice of this increment in the potential energy for the single surface. This is 8 pi r dr into 2. So what I write here, the increment in potential energy for a soft bubble is equal to 16 T pi r dr. Now what can we have to write the work done expression. The work done expression is the force into dr, the displacement of the molecule from this initial sphere to the expanded sphere. So this is the force is the pressure into surface area 4 pi r square. So now the expand this bracket, the expression of the work done is equal to pressure into 4 pi r square dr. Now by making equal this work done with the increment in potential energy, P into 4 pi r square dr is equal to 16 T pi r dr. Now dr is cancelled out, r power 2 is cancelled out, then pi is cancelled out. In left side P into 4 is remaining, and in right side 16 into T is remaining. 16 into T is remaining. So the relation between excess pressure and the surface tension is pressure is equal to 4 T by r. When the two surface, that soft bubble is a two surface problem where inner and outer surface is expand, the excess pressure is equal to 4 T by r. For this liquid drop or the air bubble inside the liquid, the single surface is contact with air and the single surface is expand. For that case, pressure is equal to 2T by r. So this is a these two are very simple question. Maybe we will see in some exams. Let's move to our third problem, that is excess pressure across a curved surface. We have already derived that for liquid drop or air bubble in liquid, the excess pressure is equal to 2T by r. For this soft bubble, the expression of excess pressure is equal to P is equal to 4T by r. Because of two surface, this is 4T by r. Because of expansion of single surface for the liquid drop, this is 2T by r. Now this, what is this r? This is r is the radius of the sphere. What we have derived before two cases, both liquid drop as well as the soft bubble, this is spherical, that is symmetrical body. But the why we need this for the curved surface derivation for the excess pressure? Because you can see this balloon is not a symmetrical body or spherical body. So for this we have to find what is the excess pressure across a curved surface. So we can take the very infinitesimal surface of this on a balloon. This is a three-dimensional image. You can check it. This is the surface, some infinitesimal surface of this balloon, where P0 is the outward pressure and P1 is the inward pressure. The difference between P0 and P1 is our excess pressure. Suppose somehow the excess pressure P is increases to P plus dP. What happened? Like previously, this surface also have to increases. So let's see, this is in magnifying image. So initial surface is our A, B, C, D. Okay, A, B, C, D. When the expansion is happen due to the increment in excess pressure, what happen? You can see this surface is initial like this. Then the balloon is try to expand. So what happen? This, if this is our B point, this is our, you can see this is our B point. Then B point of balloon. Then this is B point is increases to B prime. So B point is increases to B prime. The length between B and B prime is dz. Okay, and let's come to the mathematical part. So initially the A, B, C, D surface, the length of surface is AB is equal to x and BC is equal to y. So what happened? Due to the increment in excess pressure, this surface is increases to A prime, B prime, C prime and D prime, and it's the move in z direction by, every point is move in z direction by dz distance. So B prime is equal to dz, and the expansion in A B direction, that is A prime B prime x plus dx, and B prime C prime is equal to y plus dy. So here what we see, that there is due to increment in excess pressure, the increment is area happen. Since the area is increases, there is some increment in potential energy. The next aim for us is to derive the expression of increment of potential energy in term of surface tension. So area of ABCD initial surface, that infinitesimal surface, is x into y. What if you take a very small infinitesimal surface, it become a rectangular. So length AB into BC is the area of ABCD, which is x into y. So the area of the increased surface, expanded surface, is A prime, B prime, C prime, D prime is equal to x into dx. This is A prime, B prime distance and B prime, C prime distance, y plus dy. Now the open the bracket and multiply these two terms. What we get? X into y, x into dy, and then y into dx and dx dy. This dx and dy can be negligible due to very small. So increase in area is equal to difference between the expanded surface minus the initial surface. The expanded surface area is xy plus x dy plus y dx minus initial surface xy. So xy is cancelled out. This one is x dy plus y dx. Now the increment in potential energy, we know that the expression for the increment of potential energy is surface tension into increment in area. So expression of potential energy is equal to surface tension into x dy plus y dx. This is our equation 1. Let's write the expression for this work done. The expression of work done. So what is the excess pressure? Excess pressure is difference between the outward pressure minus inward pressure. So due to this pressure, the surface is moves in dz distance. Okay, this is B to B prime. So some work have been done. This, the expression of work done is equal to P into xy into dx. This is pressure into area. This is force, and dz is the displacement. So work done, what is the expression of work done? The P into xy into dz. This is equation 2. By comparing equation 1 and 2, we can write in left side Tx dy plus y dx is equal to P xy dz. So this is our equation 3. Next step is what we will do. We will replace this dy and dx in equation 3. For this expression of derive the expression of dx and dy, we'll go to a little bit geometrical part. This is our initial surface A, B, C, D. Please right now follow my crossers, otherwise you cannot understand it. A, B and AC. Suppose A, B and AC is very small, very small. What we'll see, if A, B and BC is very small, the center of curvature for this AB and AC just lies below the point B and somehow coincide. We can assume it can be coincide if you make very close this sphere, okay, this circle, okay. So this point is O. O is the center of curvature for both AB and AC. The distance between OB is R, which is the radius of curvature. Next, move to our PDF. So you can see when AB is very small, we can treat it as a straight line. This is AB, and the just below the B, O is the center of curvature for the AB and AC, and BC is also a straight line. So this is ABO is a triangle, okay, for our initial surface. For our this expanded surface, A prime, B prime, C prime, D prime, this one is A prime, and A prime, B prime is a straight line, very small, if you think very small. And for this A prime, B prime and B prime, C prime, the center of curvature is O prime, which is just above the O and just below the B prime. So distance between O prime B prime is R2, okay. Sorry, this is O prime B prime, okay. So this is A prime B prime is what? X plus dy, and B prime C prime is y plus dy. This is A prime B prime x plus dx. So A prime B prime O prime is also a triangle. You can see now ABO and A prime B prime O prime, both two are similar triangle. So we can write the properties of similar triangle like A prime B prime divided by O prime B prime equal to, for this triangle, ABO, AB by BO, which equal to A prime B prime minus AB equal to OB prime minus OB. This is the property of similar triangle. Now substitute all this A prime B prime AB in term of x, y, z and r. You know that A prime B prime is x plus dx. O B prime O to B, we know that this is r, radius of curvature r1, and B prime, we know the shifted in z direction, this is dz length. Due to expansion, B point is shifted to B prime. So OB prime what? Now r plus dx equal to AB we know that x, and BO is our radius of curvature r1, which is equal to dx by dz. A prime B prime minus AB. You can see from this image, A prime B prime minus AB, x plus dx minus x is equal to dx. OB prime minus OB, this is BB prime, this is dj. From this expression we can write dx is equal to ax dz by r1. This is our equation 4. Similarly, we can write for dy is equal to y dz divided by r2. Now from equation 3, if we put the equation 4 and equation 5 value, that p xy dz, left side you just see once again, p xy dz equal to t into y dx. dx जगह हम value put कौन करिबा, x dz by r1 plus x dy. dy रो value what? What is the value of dy? The y dz by r2. Now p x y dz equal to t by taking common x y dz and make the bracket 1 by r1 plus 1 by r2 x cancel, y cancel, dz cancel. So p is equal to t bracket 1 by r1 plus 1 by r2. This is the expression for the excess pressure and the surface tension for a curved surface. Okay, thank you.